No. So let's move ahead with the weather and meteorology topic. This is again one of the important topic with respect to the flying or the aviation is concerned. This is very, very important when we come to the commercial or civil aviation flying. Okay. In drone, certain aspects of weather and meteorology comes into the picture. Not until unless we are flying drones over a longer distance and bigger drones, these are not really impactful as of now. Okay. For example, like important aspect would be the visibility, important aspect would be the wind speed. These are the some of the components which definitely affects your drone flying, okay, or quadcopter flying or hexacopter flying. So let's see now what is weather and meteorology. So when we talk about weather and meteorology, atmosphere is the thing what comes into the picture. And atmosphere is a layer of gas that envelops the planet. So gases, layer of gases. Okay, that means there could be a nitrogen, there could be oxygen, there could be hydrogen, there could be carbon dioxide. So all these gases makes our atmosphere. The Earth atmosphere varies vertically and horizontally in parameters: pressure, temperature, humidity, and density. So, if you see with respect to the location, pressure, temperature, humidity, and density, it will vary not only from the horizontal aspect but even vertically. That means if you are at the sea level, the pressure, temperature, humidity, and density will differ compared to you are suppose at Lonavala. Okay, so which is almost like probably 200, 300 meters high. So there where you will probably have a different pressure, different temperature, different kind of humidity or density. So again, if you go little bit higher, maybe Mahabaleshwar, okay. So their pressure, temperature, humidity, density will again depend. So not only vertically, not only horizontally, but even vertically, it will vary. The Earth atmosphere vary with these four parameters. These are the four critical parameters of atmosphere. So pressure, temperature, density, and humidity. If you see the diagram, the layers of atmosphere, the troposphere, which is the most important layer where all our atmosphere is located. Okay, so this is starts from zero, from the ground till 12 to 18 kilometers. Okay, and this is the range in which our hot air balloon or your civil aeroplanes, civil airlines, all this they fly into this. The temperature vary between troposphere from 15 degree to minus 56.5 degree. Okay, so with this troposphere condition location, your temperature will vary from 15 to minus 56.5 degree. Okay, so as you climb up, your temperature will start dropping. Okay, it will become more and more colder. As you cross 18 degree or maybe 12, so this is basically, so the band is not exactly stop at 11 degree 11 kilometers or 12 kilometers. Okay, so there will be a mixture of stratosphere and troposphere also. So when we talk about 11 or 12 kilometers, the stratosphere start. This is the location where your weather balloons are all flying. Okay, where for measuring or understanding the weather conditions. Here the temperature would be from minus 56.5 to minus 2.5. Okay, so their temperature will vary. Okay, it is between 11 kilometers to 50 kilometers. Beyond 40 to 50 kilometers, what we say is mesosphere. Okay, mesosphere is where you will sending your sounding rockets or meteorological rockets again to monitor the weather and understand the weather and atmospheric conditions. This is the location where you will see the shooting stars or meteors. Okay, uh, the temperature will be minus 2.5 to minus 86.5 degree. Okay, this is between 40 kilometers to 90 kilometers in range. Okay, then as you climb up, there is something called thermosphere. This is little bit hotter, not little bit, I mean more hotter region. Okay, it starts with minus 86.5. So probably at the edge it could be minus 85, 86.5. As you go up, it will be in addition of higher, I mean hotter. This will be basically a hotter location. So 12 degree centigrade. So thermosphere starts from 80 kilometers to 800 kilometers. So this is the location where you will see all those spacecraft, satellites, International Space Station, Hubble Space Telescope. All these are located between thermosphere and exosphere. Exospheres, where you will start with the space. Actually you are out of Earth's gravity and you are into the space. Okay, more or less. So as you climb somewhere around 3,000 kilometers, you will be completely in space out of Earth's gravity. Okay, so that's where you will see the spacecraft and all the things moving. So within the range of, like, International Space Station is at around 400 kilometers from the Earth. Okay, so there's the temperature is 1200 degrees centigrade. So it's hotter outside over there. Okay, so that's how your atmosphere is divided. Okay, atmosphere saves us from all dangerous UV lights, gamma lights, all the radiation what we get from the sun. It is creating a protective and layer or envelope so that the life can exist on the earth. Okay, so weather is the state of atmosphere describing, for example, the degree to which it is hot or cold, wet or dry, calm or stormy, clear or cloudy. So normally we'll see now how is the weather today. If somebody asks you, so you will always see outside and see, okay, today is good. Right now, if you see outside, you will see it is clear and sunny. Okay, but not ekdam. I mean, it is not like a very clear sunny. You can see little bit haze in the weather, or the climate is little bit hazy also. Though you can see the sunlight, looks like clearer, but not very clear. Okay, as of now, the climate is little bit hazy outside. Okay, so that's how we define. So now, since we are in already entering the summer, we'll say it is hot outside. When it is in winter, we'll say it is cold outside. When it is in rainy, we'll say it is wet outside. Okay, during extreme summer, we'll say it is dry. Okay, during rainy season or something, we can say calmy or stormy. It is clear or cloudy, depending upon how the weather is. So weather is one factor in modern aviation over which man has no control. You have seen, right, in between last couple of weeks back, 2 weeks back, I think it was raining. All of sudden this it started raining. So 2 days it was raining in Mumbai, Airoli, all those locations, even in Borivali, Bhainder locations, it was raining. When I was in Igatpuri, in fact, I was in Igatpuri that point in time. Okay, that time in the evening it used to rain. So one day in the evening, it started with a very heavy wind. So we could not continue our flying activities in the evening. So we have to stop because the wind was flowing more than 15 knots. So if it is more than 15 knots, we cannot fly a drone because drone becomes unstable. The quadcopter or hexacopter become unstable. So that point in time, OEM has suggested that if the wind is flowing more than 15 knots, you should stop your activity. Okay, so meteorology is a branch of atmospheric science which includes atmospheric chemistry and atmospheric physics, which is a major focus on weather forecasting. So if you see this statement, man has no control. Though we are studying atmosphere, we have a technology, so many things. In fact, atmospheric location, the control weather stations, they are been established almost like 100, 200 years old. Any weather station you take, okay, the older weather stations, they are at least minimum 100 years old. Okay, so we have two weather stations in Mumbai. Do you know where they are?
I think
Any idea?
Colaba and Santa Cruz.
Correct. So in Colaba and Santa Cruz, we have weather station. We continuously monitor the weather of Mumbai city and nearby area. We have a major university which talks about the weather study and all the things in Pune. Okay, so though we have so much study, we have so much of data, and still a lot of time you have seen the forecast goes wrong because you really cannot 100% predict accurately. Okay, sometimes your predictions are accurate, correct, and your predictions are right, but sometimes your predictions also go wrong. Sometimes MET says that okay, tomorrow it is going to rain. It doesn't rain. Okay, but these predictions are done based on the historical data. Whatever data they have for last, they will refer last 20 years. Okay, on that particular day or in that particular segment, like last 7 days they will study. Today is like first, so last 3-4 days and next 3-4 days they will take average and they will try to make a prediction. Okay, these are only predictions, these are not accurate. They try to see also whatever based on the data they predict and then say how much their prediction is accurate. That's how they come to study, or how that's how. So more and more data you have, more accurate you will able to predict. But still, weather you cannot have a control. You never know how the weather will drastically change. Okay, like in 2023, I was going to Chennai for my medium class training. Okay, I was in the aircraft. Okay, we were on the runway. We were somewhere around seventh on in the queue for takeoff. The sky was very clear, completely sunny, everything, and all of sudden it started raining. All of sudden the weather got changed. Visibility become very low. It started raining so heavily, like next 2 hours, 2 to 4 hours, it was raining continuously. Our flight was almost delayed by 1.5 hours. So I was supposed to land in Chennai somewhere around 6:37. I landed at 9 that day. Okay, and even in Chennai it was little bit gloomy climate at that point in time, but still it was okay in Chennai. Okay, but that is the day when we had, this was in month of May, I'm talking about month of May. Okay, and this was the time when you had a heavy wind flowing across Mumbai, that big hoarding which was fall down in Ghatkopar area, and couple of people died and all that thing. You must have heard a news in the news, right? Everybody is aware of this situation. That is the same day when I flew to Chennai. Chennai, when I landed that day, it was okay. But the moment I started my training, first 2 days was little bit gloomy and little bit, okay kind of thing. But last 2 days it was raining, literally raining. Morning sessions we could not conduct. We only can fly drone in the afternoon sessions. So we flowed some 2 hours of drones, and that's what it is. Okay. After that, we have to end our sessions because again evening was very gloomy, very hot, and drizzle was happening at that point in time. So we could not really fly our drones. Okay, so meteorology, to understand the meteorological hazards, their effect on aircraft, and how to minimize the risk possessed by those hazards. So whenever I am planning a flight plan from Mumbai to say Delhi, Mumbai to Chennai, Mumbai to Kolkata, I need to study the weather. I need to first know what is the weather at my location, that is Mumbai. Then I might have to see Surat, then I have to see Ahmedabad, then I have to see Jaipur, then I have to see where I am going to land, probably Delhi. If I'm going to Kolkata, then probably in my path, probably from Mumbai to Nagpur, Nagpur to maybe in between whatever the airports are there, small or big, which I have taken in my flight plan. Those airports, I will check what is the status of weather at that location. So every airport will generate a report of the weather, current weather at that point in time. So some airport predict or publish the report of every 8 hours. Okay, so to identify weather information that is required for each flight to interpret actual and forecast weather, because see, from Mumbai to Kolkata is like 2 hours of journey. Okay, or Mumbai to Chennai is like 2 hours of journey. So I do not know right now the weather here in Mumbai is this. At the same time, what is the weather in Kolkata? I should know about it. But when I'm 2 hours later, I'm going to be in Kolkata. What could be the weather? So I should know about that when I'm flying. Okay, so this is from a civil aviation, okay, or commercial airlines. So to analyze and evaluate weather information before flight and in flight, also during my flight. Okay, as I'm flying from Mumbai to Delhi, I may encounter at Jaipur, I may encounter some turbulence. Okay, so I should know what is the weather at that point in time in that particular, or what could be the forecast for that particular location for next 2 hours or 4 hours. So I should have that information handy. ऐसे नहीं ना कि मैं वहां जा रहा हूँ और पता चला अरे वहां पे बारिश हो रहा है. Now I do not have umbrella. What to do? All the things. So even when you're traveling, like nowadays, because of technology and all the things, we always like कल अगर हमको suppose I want to go to Shimla. So I will always see what is अभी शिमला में क्या weather है, what kind of weather is there. So we study, right? Whenever we plan some kind of a trip or some outing or something, we normally see the weather, because then accordingly we can take a decision whether what kind of clothes I should take, what kind of precautions or protections I should need to take. So all that thing can help by taking. So similarly, when you're flying, you should know what is the current weather, what would be the weather down the line, 1 hour, 2 hour, 4 hours, whatever it is. Example, a long flight from UK, from London to Sydney. So these are very different locations with respect to the geography. Okay, so London is in North Hemisphere at latitude of 55 degree, whereas Sydney is in the Southern Hemisphere. When there is a summer going on in London, there is a winter going on in Sydney. So completely two different segments of weather. Climate is completely different. So you should know, in between you would be crossing probably Indonesia or Singapore, Thailand or even India, or maybe Gulf, like Kuwait or probably Muscat. How your path is, depending upon how your path is. So based on that, you should know the weather on that particular location on your flight plan. So knowledge of meteorology will at least enable the aviator to anticipate some of the difficulties which weather may cause. Okay, so that is the reason why you should, as a aviator or as a pilot, you should study weather, the meteorology. Okay, that's the subject called meteorology. So this is one of the subject for even the CPL students. Commercial pilot license का जो study करते हैं उसमें weather and meteorology is also one of the topic. So SAFE is been incorporated in the your drone pilot training also. Because today we are flying in VLOS, tomorrow we are going to fly our drones in BVLOS conditions. So I do not know, every 40 kilometers your weather would change. Okay, so if I'm sitting in Mumbai, the weather in Palghar might be little bit different. Or weather in Lonavala would be different. Okay, so that Lonavala is 100 kilometers. So, the weather would be different because of, again, altitude, location away from the sea. All these factors will change your those four parameters. What are those four parameters? Pressure, temperature, density, and what? Pressure, temperature, density, and humidity. Okay, or viscosity, what we call. So these are the four parameters will vary. Okay, so you should know with respect to the location what is the current situation over there. So how do we know? There is something called METAR. Okay, METAR is nothing but meteorological aerodrome report. METAR gives us the required data such as wind direction, wind speed needed for safe flying. The drone operation, we need to cross check the METAR for safe and secure operation where we do not risk the drone. As I said, 15 knots का wind fly हो रहा है, you should not fly your drones. Okay, beyond 15 knots, you should not fly your drone. You need to know what is the direction on which the winds are flying also. So these are some critical inputs you need to consider when you are flying your drones. From a civil airplane, METAR entire report you need to know. So earlier METAR was something like a string of characters. So those string of characters was available for pilots to send. So you will ask, like for example, Surat Airport to send you the METAR data. So earlier the METAR data was one liner. Okay, it was a one line which used to tell about what is the condition of the meteorological at that particular location. If you want the METAR forecast, you have to request for METAR forecast. So that is again another line about METAR. Nowadays, because of the technology and every airport is having its own website, so you can always check the METAR online. Okay, so let me show you a couple of METARs for your understanding. Okay, so I just have to type METAR Mumbai. Okay, so just open the first site. So whatever you see on the left side is your METAR. So you see a Chhatrapati Shivaji International Airport, Mumbai, India. It is talking about its latitude. I told you the Mumbai latitude is 19 degree, longitude is 72 degree. Elevation is 8 meters. So from sea level, the airport is at 8 meters of elevation. So height is of the airport is 8 meters. What is the current weather observation? The report was made 21 minutes ago. Okay, wind is 9 knots from west direction. Temperature is 32 degree. Humidity is 67. See, humidity is very high. Pressure is standard pressure is there. Visibility is 4,000 meters. That means 4 kilometers I can have a good visibility. I told you, na, this climate is outside sunny, but little hazy. Okay, clear hai, but little bit haze bhi hai. Okay, now what is the forecast, you can see forecast was made 2 hours 21 minutes ago. So during when this report was made, okay, the forecast is valid from 1 till 2, okay, at 12 UTC. That point in time, the forecast is that right now it is 9 knots. That time the wind probably could be 10 knots. Visibility is same as 4,000, so 4,000. Few clouds at height of 2,000 feet. Hazy, okay, temporary. Wind 8 knots from west with gust of 18 knots. And all of a sudden between you will see a lot of wind flowing also with heavy. So this is how the METEOR. So actually, if you see the METEOR, okay, this is actually the METEOR. So ideally, the pilot will, earlier pilot used to get this type of information. Okay, so this is very difficult. You should know what are these it is showing. This is, for example, 4,000 hazards, okay, NSC, no significant change, okay, or your what is this, pressure is 1099, okay, 109, or 3225 is your basically your temperature, and what is that called, humidity, or basically, and then you see here 9 knots, okay, or 2800 is basically taken from some parameters. I mean, here from here, so not all are displayed over here, but then again this is the time, okay, when it was taken, okay. That is how it is. VABB is nothing but is the location for Chhatrapati Shivaji International. So every airport will have these names from the aviation perspective, that VABB, okay, Victor Alpha Bravo Bravo, station ID it is called. Let's see some other location. Let's see now Surat, okay. So Surat has little bit different type of website. So, but still they give the same information, okay. So you can see METEOR for Vasu. Vasu means VASU is the station ID, okay, Surat Airport. So you can see it's a clear 34 degree, 9 knots from 22 degree, that means from west. Visibility here, see, it is 6 kilometers. In Mumbai, it was 4 kilometers, 4,000. Okay, non-ceiling wind, it is a clear sky. Atmospheric pressure is standard 108 hectopascal. Okay, so if you see, wind is flowing from some this direction. Okay, this is how your orientation of your landing strip is there on the airport. So north south, the angle is little bit tilted. You can see here 22 and 4 knots from here. Okay, then there are certain graphs because they are constantly monitoring it. That's why they have given graphs also. If you want to deep dive and understand more, you can do it from there. Okay, so this is METEOR for Surat location. Let's see another example. METEOR for Delhi. Either see, this is how actually the METEOR used to come earlier. Okay, this is very, I mean, until as you know how to read this statement, then you will get it. Or else you can go to AllMetSat. Okay, this is similar. So here Indira Gandhi International Airport. Now see the elevation of that airport with the sea level. It is almost 220 meters. So Delhi Airport is at 220 meters height from the sea level. Okay, latitude of Delhi is 28 degrees. Longitude is 77. Report was made 25 minutes ago. Okay, it is winds are flowing at 8 knots from east direction. Okay, and gust almost for 18 knots. Temperature here is 35 degrees. Humidity is 37. See here, humidity was 67. That's why we feel what we feel. What is that called? Sweating, right? In Mumbai we sweat, but here humidity is less, 37 degrees. So we will not say it's a dry summer kind of thing. Pressure is again standard. Visibility is 3.5 kilometer, little bit hazy. What is the forecast? You can see 10 knots. Visibility is 4,000 meters, that is 4 kilometers, and all that thing. Okay, so that is how you can understand. So this is the forecast METEOR. Okay, so pilots normally see this METEOR and they interpret, okay, with this, because this was actually earlier you didn't have a LCD panel or this thing. So this used to display on their cockpit panels also. Those LED panels were there. So there was limitation of the words. So a lot of time the information in their cockpit used to come in this format. Okay, that's why the METAR is. But nowadays, because of the technology, and now cockpits are having LCD panels now. Okay, or display panels are there, or tablets are also available for pilots. So they, on the tablets you can get all this information in much easier. Like you see how Surat Airport has made their METAR reports, right? More easy to understand, more UI friendly kind of thing. Okay, whereas this is still like a textual kind of thing. Okay, so more and more less will. Then there are a lot of apps. Okay, so there are apps which are available for people to use and understand the weather forecasters. Okay, so Meta, there are several mobile apps that provide real-time metadata. Some of them are below mentioned. So UAE forecast, good to fly, Dronecast, Drone Buddy, Air Data UAE, or Windy. So I have been using Windy for almost for a couple of years now. So Windy is a subscription-based platform where you get a very good, accurate information. So if it is going to become a cloud, it gives you the animated output also, like how the wind is going to flow, how the cloud formation is going to happen. All that things is available on these apps, and it gives you forecast for like a period. Like you can see the forecast for next 3 days, 7 days, kind of thing is available in apps. Any questions so far on the METAR? So before your flight communication, you should always refer METAR also to see the climate or weather condition before your operations. Since currently we are not flying the drone in BVLS, BVLS condition is we can normally see how the climate is outside, right? Physically seeing the actual weather over there, wherever we are going to conduct the flight. Okay. Okay. Any questions so far? No. So let's proceed. So international standard atmosphere. The international standard atmosphere is a static atmospheric model of how the pressure, temperature, density, and viscosity of Earth atmosphere change over a wide range of altitude and elevation. So international standard atmospheric study has created a table, a reference table. See, this is not accurately, but for a reference purposes, based on the altitude and elevation and the location. They have a table. The ICAO has published a table where it gives you some rough idea about what could be the pressure, what could be the temperature, what could be the density, or how it could be the viscosity. It has been established to provide a common reference for temperature and pressure and consists of tables of values at various altitude plus some formulas by which those values were derived. Okay, so there is a option. So same concept is being used by apps now. So in app you get everything ready made. So whatever the computation is required, you just feed the data. When what you information you require, accordingly you will get to know the temperature, pressure, or other parameters like density, viscosity at that given point in time. Then it has all the historical data about the weather. Based on that, it try to fit and give you the as much as accurate. It could be like 70-80% of accurate information for that particular location. Okay. So international standard atmosphere, that is ISA, ICAO published the standard atmosphere that MSL at mean sea level, the temperature would be 15 degree Celsius. The pressure at mean sea level would be 1013.25 hectopascal. The density at the mean sea level will be 1225 grams per cubic meter. Okay, or the lapse rate. Okay, if you see at the mean sea level, the temperature is 15 degree. So what would be the lapse rate I want to find? Every 1000 feet I climb, my lapse rate will reduce by 1.98 degree Celsius. To round off, I would say 2 degree per 1000 feet. So from Mumbai, if I climb up to 1000 feet, let's say I go to Lonavala or Mahabaleshwar, okay, Mahabaleshwar could be 1000 feet approximately. So at that location, the temperature will drop from 15 degree to 13 degree. If I go further height, like I go to Uti, I go to Kodaikanal, all those locations, which are almost like 7,000, 8,000 feet. So that location, the temperature will be more. That's why you see Uti or Kodaikanal, these locations are very cold. Even in summer you feel cold, those locations. Okay, so it will be very, very cold. So you see, divide. So 8. So if normal temperature of Mumbai as of now is, let's say, what was it, 35, right? 35 degree. So every 1000 feet your temperature will drop. So if you drop by 8000 feet, so 8000 into 2, so 16 degree minus karo 35 mein se. So it will be how much? It will be roughly around 19 degree. So it will be cold at that location. Okay, so that is how you calculate roughly the location. Similarly, pressure or density you can find with respect to this. So you need to, these are all base setting at the mean sea level. Okay, standard atmospheric settings. So at mean sea level, the temperature would be 15 degree, the pressure would be 1013.25 hectopascal, density would be 1225 grams per cubic meter. Okay, any questions over here on the standard atmospheric pressure? Atmospheric conditions? No, let's move ahead. So standard types of pressure. In aviation community, the term QNE, QNH and QFE are used to describe standard pressure, local altimeter and field elevation respectively. Okay, so standard pressure कहाँ पे है? हमने बोला था standard pressure at mean sea level. Okay, so if you see QFE yesterday we have seen the diagram. I have shared in the group also the picture, right? I showed you at the start of the session also. Okay, where you have to measure QNE, where you have to measure QNH, where you have to measure QFE. So if you see QFE is nothing, field elevation. FE is field elevation. Field elevation is near the airport or the aerodrome or on the ground. So QFE is the altimeter pressure setting at the takeoff location, which indicates 0. So yesterday I asked you, before the takeoff, what would be your QFE setting? What would be the QFE setting before the takeoff? Or what would be the height of the drone?
0.
Correct? So QFE will show you 0 as you climb or as you take off. QFE will start rising. So it will be 1 feet, 2 feet, 10 feet, 20 feet, depending upon your height. Okay, QNH is nothing but nautical height. QNH is an altimeter pressure setting at the takeoff location reduced to MSL under the ISI condition, which indicates altitude. Because QNH is nothing but QFE plus the altitude. अभी मुंबई का altitude कितना बताया था? मुंबई एयरपोर्ट का altitude we saw in the meta.
8.
So QFE plus 8. So when before the takeoff, your QNH will show 8, not 0, because that 8 will add on to your QNH. Your QNH will be QFE plus the height of the airport. Okay, so your QFE is anyway 0, but that elevation is 8 meters. So your QNH will be 8 as of now during the takeoff. As it takeoffs, your 8 and whatever the height you have taken, maybe 2 feet, 10 feet, so it will be showing up. 2 feet hai to it will become 10 feet. 10 feet hai to it will become 18 feet. The QNH will become 18 feet with respect to the nautical height. Whereas when you are in a deep ocean or in the sea, okay, there we have to follow standard atmospheric pressure. So whatever standard atmospheric pressure hai, that time whatever altimeter is showing, you have to set your altimeter at standard atmospheric level. Whatever the flight height it shows, that is your flight level. So that means your altimeter is set to the standard atmospheric pressure, okay, which is called as flight level. This is only applicable for civil airlines or aeroplanes, not for drones as of now. Okay. So for on drone perspective, you only have to consider QFE, that is the field elevation. Yes, Parag.
I just wanted to check. You answered that at the latter part where whether these things are applicable to drone, but you said it is not. So I was about to ask you the same question
Yeah, yeah.
whether
So
these are
yesterday
applicable
also
to
I
drone.
told you you have to focus on QFE, the field elevation. That is where actually a drone, because we are not flying the drones because drone doesn't know the height. Drone doesn't use altimeters. Drone use terrain radars. Okay, so it actually sends the beam and it gets the reflection, and that's how it knows the height. So it can get only height with respect to the ground. Okay, अगर वो पानी के ऊपर उड़ेगा ना तो उसको रिफ्लेक्शन नहीं मिलता है. Okay, reflection gets scattered on the water. Okay, that's why you can't get the weight. So that's why you don't fly drones over the water areas. Okay, so then if you are flying the drone in a water area, you have to add some more sensors to it. Okay, then only you can fly. There are drones which are designed for that particular purpose or that activities. So any question on QFE, QNE, QNH? No, right? So again, yesterday I've shown this diagram. So this is your altitude with respect to the sea level. QNA is with respect to the standard atmospheric level. That is what we call as the flight level. Most important is the QFE, the height. Okay, so height is basically nothing but the height from the ground. Okay, with respect to your. So for Mumbai, it is 8. For Delhi, it was how much? We have seen in METAR.
20,
22.
22,
22 or 220.
220, yeah.
Sorry, 220.
Right, 22 220. Okay, so that height it is. So that will add to your QNH when you're talking with respect to altitude. Okay. So now after the pressure and temperature, let's see the wind. Okay, so measurement of wind. Anemometer is a device that is used to find the wind speed. It is an analog as well as digital. So if you see, this is a digital anemometer which is being used. But if you go to weather stations or locations where the measurements are done, so you will see there is something which device which is continuously rotating, right? So that there are 4 cups, and there is a ball bearing, and then that rod will go inside the weather station, and there are gears in the below. There is a device which actually measures the speed on which that cups are rotating. Okay, so that will give you the wind speed. Okay, and then there is a pane also. There is a arrow kind of pane is there which tells you the direction of the wind. So you can see those devices and understand the direction of the wind, and looking at the readings on your anemometer, the analog anemometer, you can know what is the speed the wind is currently flowing. Okay, so analog anemometer are fixed, while digital anemometer are pocket size and compatible. So this is available on Amazon of almost like 300 to 400 rupees. Okay, these are very small handheld device. You can use it for checking the wind speed. Okay, and also you can point it accordingly. You know what is the direction. The wind speed should not be more than the permitted limit by manufacturer at the time of drone operations. So the OEM knows what is they study. They make documents which says that my drone is capable of flying in so and so wind speeds. So normally beyond 12 to 15 knots, no drones are advisable to fly under those conditions. Okay, so beyond 15 knots, or even sometimes some drones are capable, like heavier drones are capable of flying in 20 knots also. But ideally, beyond 15 knots, you should not fly your drones. Okay. So how do you measure? This is one device, anemometer. The second one you would have seen multiple times at the airports or aerodromes, or even at the weather stations, something called as windsock. It is a light, flexible cylinder or cone shape mounted on the mast to show the direction and the strength of the wind, especially at an airfield. Right. So you will see, would you have seen this kind of thing? It is a white and orange or red strips on the wind six, are not for decoration, but they are actually indicates the relative wind speeds. A lot of people get fancy by the color red white kind of thing, or sometimes it is orange white kind of thing. So people think, "Arey, ye kya colorful laga hai?" But they are not basically for color, but knowing the position. Like if you see this first position, there are 5 sections into it. 1, 2, 3, 4, and 5. If the first section is horizontal and remaining 4 sections are on bended, then the wind speed is approximately 3 knots. If 2, 6 knots. If 3, 9 knots. 4, 12 knots. All 5 sections are horizontal, then the wind is flowing at 15 knots. Okay, so if your wind sock is in this direction, you should avoid. Again, you can see the strength. Sometimes it is wind is flowing at 15 knots, but it's not at very high pressure. Okay, so if it is at very high pressure, 15 knots and above, you should always land your drone immediately. You should not continue with your operations. Are we clear on how to rate the windsock? So we have a windsock at our location also. At our flying location, when we are flying, we'll always see the windsock position, and based on that, we'll fly our drones accordingly. Any questions on windsock? So it is always multiple of 3. So first section 3, second section multiply by 2. So 3 into 2 is 6. Third is 3 into 3, 9 knots. 4 is 4 3s are 12, so 12 knots. Last all 5 are horizontal. That means it is 5 into 3. That is 15 knots of wind is flowing. So if your wind is flowing more than 15 knots, you should immediately land your drone. Okay, or it will become little bit unstable to fly. Unstable means what? The drone has to make a lot of computation to make it more stable. That is how you will utilize more power of your battery. Your battery will be used in computation or making the drone more stable in a heavy wind conditions. Correct? Any questions on the wind, or we are good to move ahead? So let's see different types of wind. As we see wind, the wind are like a gust, like we have seen in a METEOR, the gust was talked about 18 knots. Okay, so it is a heavy wind. Wind speed is more than 15 knots. So it was telling that in the Mumbai there would be a gust of 18 knots. So gust is nothing but a sudden increase in wind speed, often with change in direction, lasting less than 1 minute, and it is a local effect. So a lot of time you would have encountered this. Okay, आप जगह पे खड़े हो और all of a sudden you will feel a very huge wind flowing around it. Okay, so that is called as gust. It will last less than 1 minute, just आएगा और चला जाएगा, last 1 minute, and it is a local effect. Not necessary a person standing away from you 100 feet may also feel this. Okay, so gust is local. Okay, particular location, maybe 100, 200 feet, even 500 feet, person may not feel the gust. So gust is the local phenomena. Okay, all of a sudden. Lull is a period without waves or wind. So you will see silence. Immediately after the gust, there will be a very silence, calm. Okay, it's a period without waves or wind. So that is called as lull. Okay, what is squall? Squall is again sudden increase in wind speed, often change in direction, but lasting for 1 minute or more. Lasting for 1 minute or more. Gust is less than 1 minute. Squall is lasting 1 minute or more and can cover wide area. So earlier it was local effect. Here it is talking about cover a wide area. That means even person standing 500 feet or 500 meters away, he will also feel this wind. Okay, so that is called as squall. Squall covers a wide area. Squall is really important to be predicted. Carelessness on the part of the squall can result in crash of drone and hence loss. So squall, since it covers a wide area, it can impact your drone operation as it is lasting for 1 minute or more also. So when you feel the skull or you see the skull is happening, you should immediately land your drone. You can't take it for granted, or you can't be carelessness at that point in time. Okay. Then if your wind is flowing at 33 knots, the standard normal is 15 knots. Double of normal wind speed, that is more than 30 knots or 33 knots, is called gale. Okay, the gale exists when wind speed exceeds 33 knots. Hurricane exists when the speed is 4 times of your standard normal wind speed. Okay, that is 63 knots. More than 60 knots. Okay, is your hurricane. Okay, so normally you will not fly your drone in Gulf conditions or in hurricane conditions. Clear? Okay, so that's about the wind. Now cloud. Cloud is a mass of a minute water droplets or a tiny crystal of ice formed by the condensation of water vapor in a free air at a considerable elevation. So you'll always see cloud in the sky in the height. As the cloud are formed at some height over the surface of the earth, they take various shapes according to their height, expanse, density, and the transparency of the clouds. They are grouped under four types. So you can see that depending upon their location, the size, the shape, density, the way they look, the transparency of the cloud will tell you the types of clouds. So there are four types of clouds: cirrus, cumulus, stratus, and nimbus. Okay, so there are four types, major four types. Lot of some people make cirrus, cumulus, cumulus stratus. A lot of people have done a lot of confusion, but for understanding purpose there are only four types. There sometimes there is a mixture of cirrus and cumulus. So लोग क्या बोलते हैं, cirrus cumulus type of cloud है. See, that is wrong actually. Okay, you cannot mix the types. There could be, at the same time cirrus clouds could be also there and cumulus clouds also there. But to identify the clouds, there is a certain patterns. There are certain way to identify. So you can only identify cloud based on four types. काफी लोगों ने confusion create किया कि they combine these two types, any type, stratus nimbus type clouds. There is nothing like stratus nimbus kind of thing. Okay, stratus or stratus cloud, nimbus clouds are at the same time. You can have stratus and nimbus at the same time. You can have cumulus as well as stratus at the same time. You can have cirrus and cumulus also, but doesn't matter that कि वो दोनों cloud exist हो रहे तो उनको cirrus and cumulus बोलो नहीं. Cirrus will be called as cirrus, cumulus will be called as cumulus only. So let's see now what is cirrus clouds. Cirrus clouds are formed at height of altitude of 8,000 to 12,000. They are thin and having a feathery appearance. They are always white in color. Do you see the picture? This type of clouds you see, these are cirrus clouds. Okay, these are called cirrus clouds and they are at very high height. Okay, these are normally formed at very high height, 8,000. In fact, last week, if you would have seen the weather, especially on Friday and Saturday, we had a weather of something like this. So you would have seen a lot of cirrus clouds that point in time. In the next days, that is Saturday or Sunday morning, it was all cumulus clouds were there in the morning. Okay, so cumulus formed at height of 4,000 to 7,000 meters. They exist in patches, can be scattered here and there. Okay, cumulus looks like a cotton wool. See the difference in the type of the clouds. So looking at the cloud, you can tell. If both type of clouds are there, you should not call that as a cirrus cumulus cloud cycle. No, these are cirrus clouds, these are cumulus clouds. So they are different. So they're, see, with respect to the ground, sometimes you see both clouds at the same location, but at the height they might, because you are seeing the sky in 2D, you are not seeing it in 3D. So you will not know whether this cloud is up or down, okay, based on the location, because this is from 4,000 to 7,000, whereas this is from 8,000 to 12,000. So definitely your cirrus clouds will be little bit higher, whereas cumulus clouds are little bit lower. Okay, so understand their positions. They are at different positions. So cumulus will be always at this height. Cirrus will be at this height. Okay, so clear, feathery appearance and white in color. Here they are scattered here and there and looks like a cotton wool. Okay. Now stratus. Stratus, these are layered clouds covering large portion of sky. Here you are seeing all these are in patches. Okay, small patches. Not necessary the cirrus cloud what you see in Mumbai will be visible in Palghar or maybe in Surat. Okay, in this scenario, it will be local. These are more or less local location clouds. Okay, but whereas stratus covers large portion of the sky. It could be spread across Mumbai. It could be spread across a district probably. Okay, probably full Mumbai, Thane location, all that thing. So big area, large portion is covered. Okay, these clouds are generally formed either due to loss of heat or mixing of air with the different temperatures. So this normally you see in month of May and June. Okay, so this is basically happens during when the evaporation take place. Okay, so in Mumbai you will see in May, June. Okay, this type of cloud formation. Nimbus clouds are black and gray. So looking at the color itself, you can understand this is nimbus. Okay, so a lot of times stratus and nimbus also occur at the same time. Okay, so nimbus clouds are black and gray. They form at the middle level or very near to the surface of the earth. They are extremely dense and thick, so they don't have any shape. So in winter, sorry, not winter, in monsoon, you will see this type. So your complete Mumbai city is engulfed by the nimbus cloud. So you will see nimbus cloud, no visibility. You can't see aeroplane flying or even the buildings and all the things. You know, especially if you're staying in high towers and all that, you can see these clouds. Okay, so this is the time when you have rainy season starting or prior to the rainy season or during the rainy season, you will see these clouds. So clear on the four types of clouds: cirrus, cumulus, stratus, and nimbus. Okay, so what is the weather impact of UAE operations? So if you see the cloud base at below the 9,000 feet, 900 feet, or distance to the cloud at 2,000 feet, normally you will have wear loss impact. Okay, as the cloud cover is more, your visual line of sight will get impacted. Again, visibility is less than 3 miles, okay, or 3 kilometers. Okay, again you will have wear loss impact. Fog, cloud, or precipitation. Airframe, there will, because of the fog and cloud and precipitation, airframe will also have a load. Short circuiting of electronics. Again, we loss impact will happen when sometimes icing happens. You know, in a colder area, like if you're flying a drone in northern states like Delhi, Simla, Kashmir, all those locations, Punjab, Haryana, those locations. Okay, so a lot of time you will see icing happening on the frame of the drone or on the aircraft also. So critical performance, safety issues, loss of aircraft. So a lot of time, even the civil airlines, you know, have a lot of accidents because of icing. You can search on YouTube, you know, the aircraft crashes due to icing. You will get plenty of evidence of that. So earlier, the aeroplanes, you know, the commercial airplanes was not equipped with de-icing strategy or de-icing components. But now new aircrafts, especially from Boeing and Airbus, all the bigger aeroplanes are always equipped with de-icing functionality. Okay, whereas smaller aircraft like Cessna or any other small, you know, small charter planes, they are not. Some are equipped, some are not equipped with the de-icing functionality. Okay, lightning also causes a lot of time drop of communication due to radio frequency. A lot of time you will see disturbance in the communication when the lightning is happening. Okay, wind or wind shear, that's the huge wind flowing, loss of control, inability to return to home, or mission failure. So if you are having all of a sudden you are flying a drone, this is applicable more or less for a fixed wing drones. Okay, when you are flying a longer distance, in that point in time, like you are flying from Mumbai to Surat, okay, and you are in between Dhanu, and you all of a sudden you get a huge wind shear. Okay, so in that scenario, you should feed your drone with the information. Like in case of such kind of a wind shear is happening, what should happen? Whether the drone should continue flying further, or whether drone should come back to its base location, or whether it should land at the nearest suggested location in the flight path. Okay, the moderate or greater turbulence. So normally whenever you have a moderate or greater turbulence, you always impact with your mission duration. So if there is a turbulence, heavy turbulence or severe turbulence is there, you will normally cut down your flying. Okay, or you will land your drone or land your aircraft accordingly. Okay, so you understood the weather impact on UAS operation. So this is what I was talking yesterday about the cloud distance and the visibility. So here you are standing with your remote controller or ground station. So see, if you are at, forget about the unit over here, think this as a kilometer or miles also. So if you are 0.5 miles or 0.5 kilometers, your drone is still clearly visible. But as you double your distance, right, from 0.5, you become 1 mile or 1 kilometer. Your drone will become little bit disappear or little it will not visible what it was visible at 0.5 miles. As you move, keep on away, it will become disappearing. Okay, it will not appear clearly visible for you. It will start disappearing. So 1.5 still can see, but if you see 2.5, somewhat you can see. If you are tracking, you're continuously seeing it, then probably you might see it. But if you go beyond 2.5 miles or 2.5 kilometers, see your drone visibility lose. Okay, you lose the visibility. See, beyond 3 miles, so you are definitely not able to see your drone. Okay, so ideal it is up to 2 miles. Okay, so normally we'll fly under visual line of conditions in 1 kilometer to 2 kilometer range only, depending upon your size of your drone. So again, this is subjective to the size of the drone. For example, if अगर एरोप्लेन is a huge device. So 3 माइल के दूर तो आपको आराम से दिख जाएगा, right? Because airport landing strips are almost 3 kilometers length. Okay, almost average. Okay, 2 to 3 kilometers of range. The strips are there. So you can see aeroplane very clearly in 3 kilometer, or even in 5 kilometers, 10 kilometers away. Also, you can see the aeroplane because the size of the body of the aeroplane is very big. Okay. So cloud and fog both forms due to water vapor condenses or freezes to form tiny droplets or crystal in air. Cloud can form at many different altitudes, while fog only forms near the ground. So in winter, we normally see the fog formation, right? Even today also you can see, if you go early morning or in the evening near the watery area, maybe the near the lake or some water bodies there, in the morning you will see fog forming over there. Okay, so fog is defined as a cloud with its base at very near the ground. Fog caused by the cooling. As the air cools, it's become denser and drain it to the lower areas such as river valleys, where thick fog accumulation may occur. Fog may caused by evaporation also during summer. When cool air moves over the warm air, enough moisture may evaporate from the water surface to produce saturation. So you see those divs, dewdrops forming in the early morning or in the evening. That is because the fog, actually getting because of the hot as well as the cool air mixing with each other. ये आप अब देख सकते हो, अगर आप कैंपिंग गए हो तो आपका टेंट अगर आपने देखा रहेगा, टेंट में आप रह रहे हो, एज द मोमेंट यू एंटर द टेंट, यू स्टे देयर फॉर 1 hour 2 hours, you will see there are water droplets on outside the tent. Okay, that is nothing but that is a cause because of the fog. Outside air is cooler, whereas you are inside the tent, you are breathing. So inside temperature of the tent is hotter. So hot surface is inside and cold surface is outside. So the cold air evaporates, and that's how those watery layers are formed on the tent, or even on the car also. In the, you would have seen on the car also sometimes, right? On the surface of the windshields and all that things. So icing, again, freezing rain is common ahead, like in winter location. I mean, high altitude location like Punjab, Haryana, Uttar Pradesh. Those location, high latitude kind of locations. You will see the rain converting into freezing point. So icing happens. So there would be ice on your frames. Okay, especially the wings, the tail section, horizontal, vertical stabilizer, or on the drone, the frames or on the propeller also. If the icing happens, it will degrade the performance of your aircraft or the drone. So as I told, the bigger aeroplanes are always equipped with the de-icing component. So the pilot will always on the de-icing component, so that all the ice which is formed on the wings, on the tail, or on the body will get evaporated. Or if that is not available, the pilot will require or request the ATC to send a hot water tanker. Okay, so they will put hot water on the wings or on the fuselage. Okay, that's how they will melt the ice, and then they are proceed for takeoff. Lightning causes thunder, a sound from shock waves which develop a gas in vicinity of discharge, experience a sudden increase in pressure. Lightning occurs commonly during thunderstorm as well as other type of energetic weather system, but volcanic lightning can also occur during volcanic eruptions, especially like in location like Thailand. Those location you will see volcanic eruption happening there. Volcanic lightning also occur. Okay, so whenever the lightning is happening, you have to take care of your electronics. So a lot of electronics what are used in aeroplane, they having some kind of a protection from lightning and all. Okay. Wind shear, as I talked, there are two types of wind shear. Okay, referred to as a wind gradient is a difference in wind speed and or direction over a relative short distance in the atmosphere. Atmospheric wind shear is a normally described as either vertical or horizontal wind shear. So you can see here, okay, the vertical wind shear. So it will always change in the height. Okay, so vertical wind shear is change in wind speed or a direction with the change in altitude. Okay, so you can see altitude, whereas horizontal wind shear is change in a wind speed with the change in lateral position of a given altitude. You can see here lateral position, right? Horizontal position. So that is how you define the two different types of wind shear. So change in wind speed with respect to the direction, relative short distance in atmosphere. So it could be horizontally or it could be vertically also. Okay, these are called wind shears. Turbulence, we would have encountered a lot of time when we are flying in aircraft. We would have encountered a lot of time turbulence. The turbulence are nothing but a sudden violent shift in airflow cause wind storms, jet streams, object near the plane, particularly the mountain range. So especially when you are climbing the mountain or you're going over the hilly or terrain region, also you will encounter turbulence. Or even during a change in the, like I cross Ahmedabad and I entered Rajasthan, I'm nearer into the deserts area, I will see turbulence. I will feel the turbulence area in those locations. Okay, because there is a hot air, cold air mixing is happening, and that there is a change in temperature, change in pressure. All that things will contribute to the turbulence. Okay, so there are different types of turbulence. Could be a light turbulence, normal, little bit shaky. Your aeroplane will be shaky. Not much difference will be there in the height difference in the way of the flying. So it could be a 1 meter up and down. Your aeroplane might be going. Okay, moderate turbulence could be 3 to 6 meters rise and drop, but severe would be 30 meters. Okay, so at moderate range, your drink may spill. You might your glass of water or glass of whatever drink is there, it may fail. Okay, but when you are talking about severe turbulent 30 meters rise and drop, so it will be very difficult. So that point in time, the pilot will request ATC to give a different coordinates for the height. So based on the condition, the ATC will either tell you to drop or maybe take the alternate route. Okay, maybe ask you to roll right or roll left or head towards the right, take some distance and then fly on a different path. Okay, and then come back after certain flying, come back on the original path. That is how the ATC will instruct the pilot, and his pilot has to take the correction measures when there is a severe type of turbulence. Okay, so that's all about weather and meteorology. So any questions on weather meteorology topic? This is also a little lengthy topic. I'll just summarize. Earth atmosphere varies vertically and horizontally parameters from pressure, temperature, humidity, and density. As you climb, your temperature drops. Okay. Standard settings. Okay. Standard setting meteorology is a study of chemistry and physics for the atmosphere. Okay. Basically, use this is help to predict, okay, to know the current weather and know the weather down the line, maybe 2 hours, 4 hours, 6 hours, depending upon your requirement. Okay, METAR is a data which is available for pilots to understand the current and the forecasted weather condition of that particular location or particular airport or aerodrome. Okay, so METAR, there are apps also available, so based on the apps also you can know what is the METAR conditions. International standard atmospheric pressures. These are some standard settings like MSL. At MSL, the temperature would be 15 degree. At MSL, the pressure would be 1013.25 hectopascal. Density would be 1125 grams per cubic meters. The difference in the temperature every 1,000 feet will decrease as you increase the height. Okay. So types of pressure: QFE, QNE, QNH. So basically, from a drone perspective, we only have to follow QFE, that is the field elevation. If we are talking about QNH, we have to field elevation plus the height at which the airport is required or is at that height, that add you have to add, and then you have to tell QNH. QNE is basically within the sea, deep sea oceans kind of thing. Okay, measurement of wind can be done through anemometer. It could be analog or digital also. You can use windsock also. This windsock is most of the time available at the airport or even at the flying locations. So gust and lull, sudden increase in wind speed, change in direction, lasting less than 1 minute, and local effect is called gust. Lull is the period after the gust. Okay, silence period. Skull is sudden increase in wind speed, change in direction, lasting 1 minute or more, can cover wide area. You cannot avoid squall. So if there is a squall is there, you should always land your drone immediately. Gale and hurricanes 33 knots, hurricanes is 63 knots. In both conditions, you should not fly your drones. Okay, cloud, four types of cloud: cirrus, cumulus, stratus, and nimbus. Okay, so cirrus is feathery appearance, white in color, at 8,000 to 12,005, whereas cumulus is 4,000, 7,000, exist in patches scattered here and there, and looks like cotton wool. Okay, stratus are layered cloud covering large portion of sky. Okay, and they are formed due to mixing of heat with the cold air. So different temperatures they cause the stratus clouds. Nimbus clouds are black and gray. By looking at the color itself, you will be able to tell nimbus cloud. This is mostly visible during the winter season. Okay, or when it is supposed to rain, that time you will see a black and gray clouds. Okay, so these are all impacts. So especially your VLOS impact or the performance impact could happen because of the weather hazards. Okay, visibility, as I be told, within 1 kilometer, 2 kilometers, max 2.5 kilometer will be a normal visibility. So now visibility is again subjective to people. Okay, cloud and fog. Cloud is always forms in air, whereas fog is always near the ground. Okay, so we have to consider fog, icing, lightning, wind shear, and turbulence. So if there is a severe turbulence, we should always try to avoid that. So since the flight is in flight, we cannot land that flight. Okay, so we have to take a alternative course of flight. So ATC will guide you to change your path accordingly, and later on you can join the same route again back. Okay, after some kilometers of flying away from the turbulence, you can fly and come back to the original route. Okay, so with that we complete our topic of weather and meteorology.